Hello everyone, this is Ray Kierna with Copter Concepts. I have been asked to show how I make the rotor hub assembly. So I'm going to try and show you the best that I can how this is assembled. I have experimented with all kinds of different rotor hubs and fly bar feathering assemblies to no avail. So I finally simplified the design and I have gotten something I think will work quite well. So let's go over the assembly for you. Okay, here you see a fly bar with Hiller paddle assemblies on it. Now I've experimented with this particular rotor hub assembly on and off to no avail. I mean, I had one great flight with it when I had the Hiller paddle assembly on the orange helicopter, my Halloween helicopter. It flew great. I tweaked one of the paddles here, and when I did that, the rotor hub was not stable anymore no matter how many times I adjusted it. So I decided to go with this assembly, which is a weighted fly bar assembly that has lead weights on each side of the fly bar. Now this assembly seems to be working quite well, and you don't have to adjust, opposite pitches as you do on the Hiller paddles, because these are 8-degree positive pitch, and you can pitch them up and down to adjust which rotor blade is flying higher than the others, but I did find that quite difficult to do. As was with the weighted fly bar assembly, you don't have to adjust pitch. It's just weighted, it's balanced, it works perfectly fine. Now here is the main rotor hub assembly, which is just made out of solid basswood. 1/16 of an inch thick. On each end is 5 32nd inch diameter aluminum tubes. The slots are cut. These aluminum tubes are placed in there. Each one of these tubes are about 1/2 an inch in length. The rotor hub itself is 1/2 an inch wide by 2 inches long. Now you'll notice that there is a center slot cut into this rotor hub at an 8-degree angle offset. That is for the feathering pin assembly, which is very important. Here is the feathering pin right here. That fits in this slot once it's attached to the main rotor shaft assembly. Now if you look, you see these two slots on side of the rotor hub assembly itself. That's for the fly bar assembly. So what you do is you simply place that into the slots. It's bent to a specific size, and as you see, it'll fit right into the rotor hub beautifully, and it's glued into place. I usually mount this first into the rotor hub assembly. Make sure it's balanced properly when the rotor blades aren't there. There's two ways to balance this. First, you put the rotor blades on your main rotor hub, then you're balancing it rotor blade to rotor blade. You're putting a shaft in the center hole of this rotor hub in between two glasses or whatever you got with the rotor blades on it, and you see which rotor blade is heavier. Then you weight the one that is not heavy as the other one until you get that balanced on this axis, which is the horizontal axis, and it's going to balance. It's going to be balanced this way, so it's going back and forth this way on a horizontal axis once the rotor blades are on. So if the rotor blade where my fingers are is heavy, you simply weight the opposite rotor blade until the rotor hub is balanced level like this. Once that is balanced, then you put your fly bar in, and once this assembly is hooked up to the main rotor shaft, you'll see which fly bar is heavier. Now if you cut your lead weights correctly and your rotor fly bar is of equal length, this should balance right off the board because you're balancing it this way. So you're balancing it. Once that's hooked up to your rotor hub, you're balancing it on a horizontal plane with the weights. So once the weights are hanging level, not here or here, but they're hanging level on the rotor blade, so you're balancing it, this way. So you're going to balance each blade assembly as it's sitting on, say, glasses, and that's going to allow it to tilt this way. You just so what I do is I usually assemble all this, put it on the main rotor hub assembly, and then as it's sitting on the main rotor hub assembly, you can see which weight is heavier. So it's going to be something like this. This main rotor hub fits here. You see here is your main rotor shaft. It's a 3/32 inch diameter main rotor shaft. The rotor hub assembly itself is 1/8 inch in diameter. Now that is pinned into your 3/32 inch main rotor shaft. So you drill a hole through your main rotor shaft in this hub, you pin it, there's a grommet that holds that assembly in, there's a solid wire shaft that runs from this wire to the wire pin that is holding your spur gear in place. You see that wire shaft right there. So the wire that's inside is the solid wire shaft. I think it's 0.60 in diameter. That fits inside the main rotor shaft. That prevents this shaft from bending, during flight. So you don't, because aluminum is pretty soft, so it will bend. So it's necessary. You cannot forget that solid wire shaft that's in here. If you don't have that 0.60 wire inside this 3/32 shaft, it's going to bend. Okay. Now, if you look through the 1/8 inch diameter aluminum tube, there's a 1/16 inch diameter aluminum tube that fits through this. That's drilled. It's level, and this assembly is like 1/32 of an inch on each side. This assembly holds the feathering pin, so your main rotor hub fits over it just like this. As you see, it fits right through the center hole. You fit your feathering pin in there, glue it in place. There's 2-ply plates that'll fit over the feathering pin to keep it in place. The feathering pin is glued in that side. That allows your main rotor hub to pivot on its axis while it's in flight, and the weighted flybar will do its job and it'll fly the model. Now, as you see, once you get this on there and you get your flybar with the weights on, it'll teeter this way back and forth. That's how you balance your flybar weight. So this assembly sits completely level. It's not teetering too far this way or too far this way. It sits level. So now you're balanced horizontally on the main rotor hub from rotor blade to rotor blade, and then you balance your flybar weights until it hangs level, and that's a perfectly balanced system. So I hope this helps you guys understand how I assemble the main rotor hub assembly, and it works fairly well. You've got the drive that works well. You see there that you've got an S hook on the pinion drive, so this way you don't have rubber motor damage. Now, for those of you who witnessed the crash of Sarge, I'm going to swing over in my workshop and I'm going to show you Sarge. He's right over here. He has been completely rebuilt and ready to fly. I am going to redo this rotor hub. It works, but I want to go with the newer design because this one's kind of clunky. As you see, I've got larger diameter aluminum tubes that are glued underneath the rotor blades, and I got plastic quick links, and I don't have the angle on the feathering pin. I mean, it works, but it's kind of clunky. I'd rather redo that, but otherwise that Sarge has got his cigar. Yes, I'm ready to fly. He's smoking. He's got a fuel tank. The damage was to half of this model, but it was completely repaired, and it's a lean, mean flying machine. I redid the tail assembly and fin. Those who wish to go from the styrofoam cockpit of a Hughes 300 model, you have a little bit of imagination, you can make your own carved pilot, make the seat. There's the instrument panel, rudder pedals. You see it's just, dowel rod with some balsa wood plates on there for the rudder pedals. He's got the balancing shaft with weight because the balancing point is from the main rotor shaft. So he'll be a lean, mean flying machine once I get that done. New tail rotor blades, of course, that were made out of a cottage cheese container. They work very well. So, you can review the videos if you want to build a model with a pilot in it like I did, or if you want to go with the styrofoam cockpit insert that you do see on the Hughes 300 model, you can also do that. The kit will basically, if I do kits and plans, it'll be this model, and then you can use your imagination to replace that with a seat like I did with Sarge, and rebalance the model that way. So that can be well. As you look, here's my Huey still sitting for testing. I'm going to probably have to do the rotor hub assembly on that, and eventually I will see if I can get this one off the ground. But this model weighs almost 60 grams, so it is kind of heavy, but we will see what happens. I mean, I am sorry for my absence from building. I did have some damage done to my left leg, and I suffered major nerve damage, so I don't do as much building as I have done in the past. But I'm going to try and do some more building as I can. If you like what you see, please give me a thumbs up, subscribe to my channel. Any comments that you may have, any opinions. I'm more than willing to answer any and all questions as far as building, ideas, concepts. You know, I'm very free to that. I enjoy building. I hope all you builders out there have liked what I've done. Like I said, I've been disabled, so I kind of don't get around as much as I can, so I am sorry for my absence from doing this. But I did want to do this video because I was asked by a fellow modeler to show, you know, the assembly and how I make the main rotor hub and how it's attached. So I hope that was helpful. Any questions, please feel free to ask. This is Ray Kierner with Copter Concepts, signing off for now. Thank you for watching my video.